Stella, what kind of problem is this?
What kind? Dynamics! Now that we know this is a dynamics problem, we can continue.
Our problem.
Our problem involved an elevator and a 200 kilogram box. This box is inside the elevator and it's accelerating upwards at 3 meters per second squared for 10 whole meters. It's crazy, I know.
Ooh.
So, what kind of equations are we gonna need for this, Hannah?
We are gonna need
Somebody once told me the world is gonna roll me.
some equations so that we can find the force and then the work.
Nice,
So,
because the goal of this problem is to find the work done by the normal force. So we're gonna need work equations and our favorite equation, Newton's second law. It's force equals
mass times acceleration.
Stop it. Get some help.
Okay, so using these two equations, we can start our problem. Now, Hannah, what's the first thing you want to do in every physics problem?
You want to draw a force diagram?
Yeah, you do. Okay,
So-
so here's our force diagram.
And you'll notice that force normal, even though trust me, force normal is a longer line than force gravity. I know it doesn't look like that, but it is.
And we need to remember that the only forces acting on our box are field forces and the forces that are in direct contact with it. You'll notice that even though it's in an elevator, the force of tension is not acting on the box. No.
My name is
No.
My sign is
No.
My number is
No.
You need to let it go.
So, now that we know all this, what are we gonna do with it?
We're gonna plug and chug.
Heck yeah! So, the total force is the normal force plus the force of gravity. But since they're acting in different directions, we can make the force of gravity negative, since force is a vector. And so, we know our force of gravity. It's
2,000 newtons.
because our 200 kilogram box times 10 meters per second squared, which is the accepted acceleration due to gravity worldwide, equals 2,000. So if you subtract 2,000 newtons, and we know the mass and acceleration, of course, the mass is 200 kilograms and the acceleration is 3 meters per second squared, that equals 600.
600.
So, if you add 2,000 to 600 to get the normal force, you get 2,600 newtons! Nice! And so, now that we have that, we're not done yet. What do we do next, Hannah?
We gotta plug that force into our work equation. Because we were supposed to find the work that it took for it to travel 10 meters. So we plug it in to our work equation, which is force times distance. So it's 2,600 newtons times 10 meters, which gets us
26,000 joules! Because work is measured in joules. That's awesome! So, there you go. That was some physics for you. I hope you enjoyed that.
Quality physics.
Yeah,
That's it.
we did it. Thanks. Dollar bill, dollar.